Hi, my name is Hannah Diggins, and I'm a senior at South Whitby High School. I want to share with you an experiment I did about how sleep deprivation affects high school students. I remember back when I was in middle school and later on in high school that I always had a hard time waking up for school and that I felt tired during first period almost every day. I also looked forward to the weekend when I could sleep in. I imagine you experienced a lot of the same things. Do you need to drag yourself out of bed in the mornings? Do you feel sleepy during your classes? Do you find it hard to fall asleep early enough so that you feel rested in the mornings? If you said yes to these questions, you are probably chronically sleep deprived, which means that you don't get enough sleep most nights. I wanted to explore how sleep deprivation affects high school students' ability to perform basic daily tasks. I found 6 volunteers who were willing to stay up for 24 hours straight, and I had them perform various skill tests before and after they had stayed up. So now I'm going to talk about some general information about sleep deprivation and the brain, and talk about how the adolescent brain differs from adult brains. Many studies show that adolescents need an average of 9.5 hours of sleep and adults need 7 to 8, but the majority of adolescents receive only 5 to 7 hours a night, which leaves them with chronic sleep deprivation. I personally, and most of my friends, usually only get around 5 to 6 hours of sleep on school nights. Sometimes it's because we need to stay up late to work on homework, and other times it's because we don't feel tired enough to go to bed around 9 or 10. This is due to how teenagers' brains function. Adolescent brains function differently than adult brains concerning when adolescents feel sleepy or awake. Melatonin is a hormone secreted by the pineal gland in the brain that causes drowsiness. The hormone is secreted at different levels throughout the day as part of the circadian rhythm, a 24-hour repeating biological process. Studies on adolescent sleep show that, based on secretions of melatonin, their circadian rhythm is timed later than children and adults. Melatonin secretion in adolescence occurs later at night, and the secretion turns off later in the morning. The later secretion of melatonin means that it is difficult for adolescents to fall asleep earlier and wake up earlier. When a person does not receive enough sleep for one night, it adds to the amount of sleep needed to fully restore health, which in the medical field has been labeled sleep debt. Every time a person does not receive enough sleep, the amount of sleep needed to become fully rested is added to the previous amount. Sleep deprivation occurs when a person has sleep debt. Sleep deprivation negatively affects the brain and cognitive functioning, which can lead to unfavorable symptoms. Some of the possible symptoms are listed here in the picture. When people are somewhat sleep deprived, they are still able to function, but not as efficiently. When sleep debt accumulates, symptoms become increasingly prevalent. Many people use caffeine to feel more awake and alert. I've noticed that numerous South Whitby High School students pick up coffee on their way to school. That's why I've included caffeine use in my study. Now I'm going to talk about the sleep deprivation experiment I conducted. So I wanted to answer these two questions. How much of a difference is there between a teenager's fine motor skills, reaction time, and cognitive thinking skills if they have not slept all night, compared to if they have received 7 to 9 hours of sleep? My other question is there a difference between a teenager's fine motor skills, reaction time, and cognitive thinking skills if they have not slept all night but ingested caffeine, compared to if they have received 7 to 9 hours of sleep and have not ingested caffeine? I developed 3 different tasks that I had my subjects perform to test them for these skills. One of them tested reaction speed, one tested fine motor skills, and one tested cognitive function. I selected a total of 6 high school students to be subjects in my experiment. All 6 subjects were involved in the regular sleep deprivation experiment. 4 of those 6 subjects also participated in the sleep deprivation with caffeine experiment. All of the subjects were tested when they had had 7 to 9 hours of sleep. This allowed me to have a baseline, or control for each subject, so I could compare their after-sleep deprivation test scores to their baseline scores. Both of these experiment groups then stayed up for 24 hours. The sleep deprivation with caffeine experiment was exactly the same as the regular sleep deprivation experiment, except that the subjects were given 3 8-ounce cups of brewed coffee at 1 a.m., 2:30 a.m., and 3:30 a.m. Each cup of coffee should have had around 135 to 220 milligrams of caffeine. To test the high school subjects' fine motor skills, I had the subjects thread 3 needles in a row of sizes small, medium, and large. Using that information, I then calculated their average time. I also tested the reaction time by dropping a meter stick and seeing how fast the subjects could catch it. I dropped the meter stick 3 times and then found their average reaction speed. The last thing I tested was their cognitive function. I had the subjects complete 100 basic math problems and timed how long it took them to complete the worksheet. I also calculated how many problems they answered correctly out of 100. Using the data from the subjects' tests, I created several bar graphs for all of the tests. Here are the graphs comparing the control data to the sleep deprivation data. As you can see, almost all of the subjects performed better after they had gotten 7 to 9 hours of sleep the night before. These are the graphs comparing the control data to the sleep deprivation with caffeine data. Almost all of them performed better when they had gotten enough sleep than when they had stayed up but had ingested caffeine. Drinking coffee did not improve their scores enough to make up for the lack of sleep. And then the last graphs are comparing the sleep deprivation data to the sleep deprivation with caffeine data. These results were mixed. The only test that showed that caffeine helped bring up every subject's score when they had stayed up for over 24 hours was the reaction speed test. Although all of these reaction speed tests did improve with caffeine, the caffeine still did not bring the subject's scores up to par with the control data. In conclusion, I was unable to perform statistical significance tests on my data that would allow me to make an inference about the general South Whitby High School population. However, my results did show that most students performed better when they had gotten at least 7 to 9 hours of sleep, which is what I expected to find. Thank you for listening to my video presentation.